Mike Melia, and unfortunately I have several Mikes with no last name. I believe it is this gentleman here.
That's me, Tim.
Ah, okay. Sir, if it's okay, if you can give me just one moment, let me do this. I'm going to spotlight myself for just a moment and let me do a brief introduction. So Mike Melia is a retired mechanical engineer. He's going to present a new approach to inertial propulsion, and he'll discuss a video showing a proof of concept prototype as he will demonstrate a primary drive is delivering perpendicular rotation. And in normal circumstances, any peripheral force generated by this movement should manifest itself within as part of the rotation. But contrary to this, the drive is creating linear thrust that's emanating in a 90-degree angle to the direction of rotation. So without any further ado, let me hand things back over to Mike, sir, and I will spotlight you for your presentation. Again, we're going to do, if you can do an hour, and then we'll just do Q&A after that.
Okay, Tim, I'll try and stretch it out to an hour, but my presentation is fairly simple. Have a look at complex scientific presentations I've just seen.
And Mike, I'm sorry, sir. If your audio is a little faint. Could you move your microphone a little closer?
How's that, Tim?
It's a little bit better. A little bit better.
Is that a bit better?
That's perfect. Thank you, sir.
Okay, it hides parts of my ugly mug. Okay. I think no need to you, Tim, but I'm very new at this, so I hope the assembled audience will forgive me if I make a few mess ups. My last presentation, as you just said, I'm retired. I'm knocking on in years now, and my last presentation was before a live audience, so this is entirely new to me. But a little bit of background on myself. I have been an engineer for as long as I can remember, 40, 50 years. I've been a consultant. I've started my own business, and mainly in my engineering career, I've been a problem solver. And I like to think that I can't think of a failure, but I do have 100% record on taking on a problem and sorting the problem out. It may not be the last and final end to the problem, but it will be a resolution. And many years ago, I was quite fascinated by looking at a TV in the UK, a TV documentary. It was a Christmas lecture, and it was run by a man called, I've no doubt all fans will remember his name or know of him. It's Eric Laithwaite. Professor Eric Laithwaite is the originator, I think, of the magnetic levitation motor. But he had a fascination with gyroscopic forces and gyroscopes, and that fascinated me. I wondered why a gyroscope operated the way it did, and it was a bit of an interest thing to me. And about 35 years ago, I decided to look at it and see what I could do with it, because the concept of space propulsion was talked about quite a lot at that time, and the need to provide an alternative propulsive force. And I thought, as a mechanical engineer, the answer will lie in mechanical solutions. I'm not a scientist, I'm not a physicist, I'm purely a mechanical engineer. But I look at the universe and I say to myself, the whole of the universe is one big machine. It's one big rotating machine. The physicists can get involved when it comes to the building blocks of the universe at atomic and subatomic particle level. But for the rest of us, the universe is one big mechanical machine. And more importantly, it works on rotation. Everything is in rotation. So at the time, I thought that rotation might be the answer to a propulsion system. If you look at the whole world we live in, nothing works without rotation. we can't even move along the ground unless we have wheels. So everything works on rotation. So at that time, I took an interest in it, and I started applying my thinking to a method of inertial propulsion. And I thought I would start with rotation. And I built a machine 30 odd years ago. And I got some strange results from them, but because I didn't understand what I was doing or what the machine was actually doing, I discounted it. I've discounted an awful lot of machines since then. And I've discounted an awful lot of machines I've seen on the likes of YouTube because of what I've learned by what I've done myself. So for a lot of years, I got on with my career and I sort of dealt with this as something of a hobby. Not taking it too seriously and not working too hard at it. Now, when I retired, I thought I would take another view and have a really look at this. I was determined. It's a problem. I class myself as a problem solver, and I criticize myself for not solving the problem. So I started looking at the whole thing in depth. I'll have to refer to a few little notes at the moment. I thought I'd look at it more in depth because I'm driven by it. And I thought I've always been driven to try and solve a problem, and the biggest problem of all was a viable deep space propulsion engine. Because I honestly believe without such an engine, humanity has no future in believing it can progress any further into space than the moon. I mean, rocket power is fantastic, it's wonderful, and it'll get you up into orbit. But the amount of fuel that's required and the amount of effort and expense to do that and the limitations of that fuel leads me to believe it is no real use. Certainly a manned exploration of space is of no real use at all. And we really do need what your whole raison d'etre is, an alternative form of propulsion. Excuse me one moment, Tim. I may just have a... And the machine I've come up with now, I have worked on for quite some time. And I started getting some results, very minor results, and I couldn't explain them. And unless you can explain a result and why it's happening, you cannot further it or improve on it. So it took me quite a few years to actually find out what was happening or why it was happening. And once I did that, I was able to build a prototype that could give clear demonstration of what I'm talking about, what I explained, and that it is true inertia movement. It reminds me at this stage of the jet engine. I think when the jet engine was first invented, it's Sir Frank Whittle. He got, correct me if I'm wrong, but he got something like 3 pounds of thrust from a substantial engine. But that was sufficient to prove the point. The rest is history, because once his findings were given out to the world of engineering and aeronautical engineering, then that 3 or 4 pounds of thrust developed into 300,000 pounds of thrust. And I think the apparatus I have right now is at that stage. It's in the early stages, and I consider this on a par with the jet engine. I hope that doesn't sound too conceited, but I'll let the audience be the judge once we go into demonstration mode. I will like to screen share, Tim, if I may, if I can sort of demonstrate it myself. And again, bear with me because I'm new to this.
Yeah,
So
absolutely. So Mike, let me do this again. That's the green screen share button that is down. Yeah.
Yeah, I got that. I'll put the screen share on and I'll run through a few notes that I have there, but I'll just think, was anything else I need to tell people? Just basically, I mean, my sort of whole life has been simplistic enough man, but I do have, I believe, a God-given gift to solve problems. And I've hopefully used that gift, and that will be reflected in what I'm going to show you. So if I may screen share.
There we go. Okay, and so it is showing the slide outline. Yeah, so
I'm showing a shout outline, if that's okay. I mean, I've not separated it. As I said, I'm new to this whole thing, Tim. So my presentation will be a bit amateurish, but hopefully simple and understandable. So the whole thing is about inertial propulsion. And I asked the question, is inertial propulsion impossible? The answers to this question, you have to be aware of the problem. Most people are not aware of the problem. You don't think about it. You know, who thinks about inertial propulsion? There isn't a problem because you don't think about it. But in simplistic terms, it is as follows. You have an electric motor you wish to use as a propulsion unit. If you fit it to a land vehicle, you'll need a linkage to join the motor drive to the traction of the wheels. If you fit it to a boat, you'll need a propeller to use water as the drive medium. Similarly, if fitted to an aircraft, you will need a propeller using air as a drive medium. If you wish to drive a spacecraft, what can you connect it to that will provide propulsion? Wheels? No. With no gravity, there can be no traction. Propellers, having no air or water, means no propulsion. So how and what can be attached to your motor that will provide thrust in the airless vacuum of space? The more this is thought about, the more mind-numbing the problem becomes. You will realize it is a seemingly impossible situation, and the reason why so many notable people have declared it impossible. I think if people really do think about that, they will. I had that stage many, many times. But as I said, I'm driven and I do not believe in the impossible. If I look at the next slide, because is it possible? And I believe the answer to the above is yes. Like everything else, it's only impossible until it's invented. As an engineer, my thinking was always going to be mechanical. And for inspiration, I looked at what I consider to be the power of the universe, which I mentioned before, rotation. The building blocks of creation, atoms, only exist with rotation. Moons rotate. Moons rotate around rotating planets. Moons and planets rotate around rotating suns. Suns rotate around galaxies ad infinitum. And I believe if the great engineer can create a universe of rotation, then that for me is surely a good place to look for answers. Right, and rotation creation. Ever since the invention of the wheel, rotational forces have been undervalued. We've taken them for granted. For example, we build, say, a jet engine, and we claim it works by igniting compressed air and combustible fuel, with little credit given to the rotational forces that make the whole thing work. Is it possible this lack of appreciation of the potential of rotational force is one of the reasons not enough has been done in exploring its potential as a solution for the creation of an inertial propulsion drive? I will be showing a video, and I've got the following video shows a proof of concept prototype. As will be seen, the primary drive is delivering perpendicular rotation. Under normal circumstances, any peripheral force generated by this movement should manifest itself within and as part of this rotation. But contrary to this, the drive is visually creating linear thrust that is emanating at a 90-degree angle to the direction of rotation. I've left the prototype basically exposed. A lot of people would have put it in a box to sort of hide their, if you like, intellectual property rights. But I've seen so many boxes that do not give me any answers because I want to know what makes it work. And when I built my prototype, or when I put the prototype or filmed the prototype, I wanted it to be clear to the onlooker that what they were seeing was not some kind of angled pendulum working with the aid of gravity and various other things, that they could see basically that it was a perpendicular rotating device. Now, it does not give everything away because the how that rotation is turned into linear thrust is the proprietary know-how that I have. So I'm quite happy to show the video in its form, that it shows to people that there is no trickery or gimmicks involved, that what you see is what you get. And I believe it's a clear demonstration of rotary force engineered to create recoilless linear thrust. If I may go on to the video, if I can just take another unaccustomed as I am, I'm a bit dry. I will go on to the video. Okay, right, the video, I will stop it now and again. I will hold. I will read this out, although it is part of the video. The prototype machine demonstrated in this video has no conventional drive mechanism connected to any part of the unit or the underside of the machine. I will actually demonstrate that. The drive method of perpendicular rotation is clearly visible and demonstrates no pendulum action is responsible for the demonstrable linear force being created. The mechanism is in a closed unit demonstrating no propeller power is responsible for the linear force created. The linear force being created is not random imbalance or vibration. The video demonstrates it is a powerful and controllable directional force acting contrary to the direction of the primary rotating force. Existing propulsion engines require wheels or propellers, rockets or jets to facilitate drive. The machine demonstrated has no wheels, no propeller, no jet or rocket, showing it to be an entirely new form of powered drive. This is the start of the video, the machine itself. It's been demonstrated on literally the dining room table it was built on. But you can see there is completely enclosed. It's clearly rotary. I'm not hiding that fact. It's clearly perpendicular. There's the motor, straightforward. It is driving and it's rotating something in that shell. It's not a propeller. There's no way the air can escape out of there. There's no way, as you will see, it will escape out the back. So there's nothing to hide except the final little bit of information that lies inside the machine. So I'll start it and you can have a look at that. This is demonstrating the thrust that's been actually generated. You'll see some bungee rope there that'll level it out a bit. You'll see the thrust on this will reach 5 pounds. I have actually had the unit up to as much as 11 pounds, but for demonstration purposes. Now this particular part, you will note there is a small nylon tie at the back. I'm showing the machine actually acting as a lift mechanism. It's just pulling it up and the toolbox that it is pulling up is filled. Now, on this one, as you can see, the machine is being lowered onto a standard steel tray, much to my wife's annoyance. It's one of her favorite roasting dishes. But it's just being lowered on. There is no mechanism under the machine that is facilitating any drive. So it's relying purely on the conversion of the rotary movement. Now this next one, I clearly lent it over. You can see with complete clarity, there is nothing there. There's no drive. And it is, again, reliant completely on the conversion of rotary forces into linear. The vibration that can be seen is caused by setting the machine to ease its gravity-induced weight. This gives a better demonstration of the linear force created. Video shows the machine is producing thrust from relatively low revs. Again, another thing I wanted people to see, there's nothing to hide. They are low revs, it's only in the small hundreds. If it was developed and engineered up to a high rev standard, the thrust, I believe, would be substantial. Right, you've seen the video. The concept, function, and simplicity of the drive potentially ticks all the boxes of reliability. I believe is essential to long-range space exploration. Keep it simple. Simple is reliable. The drive can be engineered up to create substantial thrust vis-a-vis the jet engine. Inexhaustible fuel supply, powered by the sun in the solar system, nuclear generator outside of it. The particular drive you've just been looking at is a 500-watt motor driven by a 24-volt battery, easily supplied by solar power. But to me, any space exploration, the engine, like everything else in life, has to be as simple as possible, because simplicity creates, if you like, reliability. Really, there's not a lot more I can say, if I can just. Well, maybe ask some questions. Shall I take you off share, Jack?
Okay, so Mike, it sounds like, let me do this. We have a bunch of people lined up for questions. Let me stop your screen share.
Okay.
Okay, and let me see. So we're a half hour. So we are a little bit ahead of schedule, but that is totally cool. Okay, and first things first, sir. Let's do this. Let me see. I'm going to remove your spotlight. Okay, so everyone, please put your hands together for Mike Melia. Give him a big applause. Mike, thank you for the presentation. Thank you for the demonstration video as well. That's wonderful. Okay, so let me do this. And again, we're a little bit ahead of schedule now. So let me go to Elzbieta Vine first. Put it back on speaker view.